our next rule is the power of a product. So for the power of a product, we need to think about what that word product means. A product means we have two items that are multiplied together. So let's go ahead and start off with x, y. And if you want to put the multiplication dot between them just to reiterate the fact that those are a product, you could certainly do that. And then we're going to take that whole thing to a power, like 3. Well, as you look at that then, once again, if you have x times y to the third power, our base here would be xy, our exponent is 3, and it means that we're going to have 3 copies of this xy. Well, okay, so we're going to have xy, one copy, another xy, second copy, xy, a third copy. Now, as you look at that though, instead of having the x's and the y's as they're written, remember that multiplication is commutative, which means I can move things around as much as I want. And in particular, I can move things that look like each other so that they're next door to each other. So let's say all these x's are going to go out in front. So that's going to be x times x times x. And then all the y's are going to go in back. So we're going to have y times y times y. Well, as you look at that, that means that I have x times itself 3 times. That's x to the third power. And then I have y times itself 3 times. That's going to be y to the third power. So we started off with x times y to the third power, and we ended with x to the third times y to the third. So in a general sense then, if I have x, y to the nth power, I can rewrite that as x to the n times y to the n. Now, how about the power of a quotient? Let's start with a specific example and see what we can play with that then. So we have x divided by y, and let's go ahead and square that. Once again, squaring means we're going to multiply something times itself, so it's going to be x over y times x over y. Well, that's x times x, that's x squared, over y times y, that's y squared. So when you look at the numerator, when you look at the original problem and you look at where we ended, what's happening here is that we have x over y to the second power becomes x squared over y squared. So both the x and the y got their own copy of that power of 2. So in a general sense then, if we have x divided by y to the nth power, that's going to be x to the nth divided by y to the nth. So as you look at these two pieces then, the power of a product and the power of a quotient, if the x and the y are connected by multiplication and you have a power of n on the outside, you can bring that power of n down to both of those factors. And the n gets its copy of the x, the x gets its copy of the n, and the y gets its copy of the n. And if you have the x and the y connected by division, when they're a quotient, we can do the same thing. X divided by y to the nth power, the x gets its version of the n, and the y gets its version of the n. Now, as you look at these two rules, it's important to understand what does work, and then it also is important to understand what does not work. Very specifically, this is the power of a product and the power of a quotient. So these ideas work for multiplication and division. They, however, do not work for addition or subtraction. So if you had an x plus y to the nth power, you can't play that same game of bringing the n power down to each of those pieces. So be careful when you move forward in this section, and in fact, as you move forward in your mathematical career, that you don't try to apply these rules when they don't apply. So once again, you cannot bring a power of n down if the x and the y are connected by addition or by subtraction. So our last rule on the board here is the expanded power rule. And the expanded power rule simply says, if you have a combination of these two, you can go ahead and bring the power of n down to a whole bunch of things. So if we have ax over by, and that whole expression is to the m power, the first thing that we have to do is check to see what operation is connecting all these pieces and parts. The a and the x are connected by multiplication, so that means the product rule is applicable. The b and the y are connected by multiplication. That means the product rule is applicable. And then the ax in the numerator and the by in the denominator are connected by division. That means the quotient rule is applicable. We don't have any additions, we don't have any subtractions, so I can bring that power of m down to every single piece here. So the expanded power rule says we're going to have a to the m times x to the m, all divided by b to the m times y to the m. So now that we have these rules, we're ready to go ahead and check out some examples. Now, on your handout, you're going to notice that there are 2 more rules. We'll talk about those 2 rules when we move on to section 5.2.